Okay, dear children who have been appearing in the Neet exam, once again I am Mr. W.Passh, coming now to some of the questions which we have uh, been doing. We have finished up to the third question, and now question number 8. The question number 8 of the Neet 2020 exam is a good question which deal with magnetizing field and then with susceptibility and permeability. But here again, actually, the student have been tricked a little bit in which the magnetizing field is not at all needed. You only know that susceptibility is 599, so mu r will be 599 plus 1 into mu naught. And mu naught is given in the question, so you will get, it will be 2.4 pi into 10 to power minus 4, and the unit you can fill it up yourself. So next time you be careful because that extra magnetizing field may scare you and you may be nervous. So be careful, remember the formula carefully and all will be all right. So now the next question is question 9. Here is transistor. So here there will be some problem regarding the NCERT curriculum which was changed in the year 2019-2020 class 12 session. NCERT syllabus, they have cut transistors, logic gates and modulation and demodulation. So this should be discussed as those who do not have any chance to go to coaching centers would be at a great disadvantage. And I do not think it is fair. It is not a fair examination field. So the other question is question 14. Fission. Fission, there is some confusion in this because the two choices, 1 and 4, dealing with krypton 103 and 36 and another krypton 101 and 36 are already there. Krypton is already there, so these two krypton coming in the choice is a great advantage to students as they have to deal with only two choices and choose the correct one. So now, anyway, this will be some relief for those students who have appeared in this exam. Question 12. Question 12 is a beautiful Newton's equation. You have to remember what you did in your class 9 and 10. The final velocity squared is equal to the initial velocity squared plus twice gs, where s is the distance, g is acceleration due to gravity, u is the initial, and v is the final velocity. This plus here means the ball is thrown in favor of gravity. If it is thrown upward, that means this will be minus. So remember, plus. So this is the one, and you can get the answer easily by solving v is equal to 80 meter per second, u is equal to 20 meter per second, and g is equal to 10 meter per second. So regarding this one, because we are dealing with Newton, I would like to ask one vital question. How big is 1 Newton? How big is 1 Newton? I asked many students, even teachers also. Some of them, teachers and students, some of them, they told me it can lift a bolero, 1 Newton. Some come down a little bit, they say it can lift a scooter. And some, quite close, they say it is the weight of that apple which fall on Newton, Sir Isaac Newton head. They are quite close. But actually it is not so. 1 Newton is 1 kg, then meter per second square. A force acting on 1 kg, if the acceleration is 1 meter second squared, that is 1 Newton. So now what we will do? We will try this. Suppose now G at one place, let us take it to be 10 meter per second squared. So when G is 10 meters per second squared, what will be this mass? So that this into 10 meter per second squared will be 1 Newton. It will be 100 gram. That means if you have a Cadbury chocolate, which is 100 gram, and if you hold it in your hand, that chocolate, which is 100 gram, the weight that you experience at a place where G is 10 meter per second squared, that is 1 Newton. So don't think it is a big thing. It is 100 gram. You hold 100 gram horizontally on your palm. The feeling of that weight is 1 Newton. So for today, we will be ending here. And I wish you good luck in the coming result. We will meet again tomorrow with another 4-5 problem that I will be doing with you. So good night, and then please uh, uh, go through this. It will help you. And I also be trying to solve some other questions from IIT and from JEE and from some state board question, which are beautiful physics questions. So good night.